All right, let's dive right in. Today we're going to tackle one of the most, believe it or not, fun parts of precalculus, verifying trigonometric identities. Now I know they can look super intimidating, but I promise, if you get the right mindset and a few key strategies down, you'll be knocking these out like a pro. So, let's get to it.
So, does a problem like this ever just make your brain kind of freeze up? You see all the sines, the cosines, the fractions, and it just looks like a total mess. And you know what? That's a completely normal reaction. But what if I told you this isn't really what it looks like?
And that's the secret right there. We are not trying to find a value for x. Instead, we are on a mission, a quest, to prove that the stuff on the left side of the equal sign can be morphed into the exact same thing on the right side. You got to think of it like a mathematical puzzle.
So, to kick off our quest, let's get on the same page about what we're actually dealing with. What even is a trigonometric identity?
Basically, it's just a statement of fact in the math world. The expression on the left is just wearing a different outfit than the expression on the right. And your job is to use algebra and other identities you already know to reveal its true form. But here's the golden rule. You can't cross the equal sign. Ever. You pick a side and you stay there.
Every good adventurer needs a toolkit. And for this quest, yours is going to have 3 super powerful strategies. Seriously, mastering these is the key to solving pretty much any identity puzzle you come across.
Okay, first up, always pick one side, usually the messier one, and work only on that side. Second, if you're ever stuck, just try converting everything into sines and cosines. They're like the fundamental building blocks. And third, bring out your classic algebra moves, like factoring and combining fractions. These 3 are your best friends on this journey.
All right, enough talk. It is time to run the gauntlet. Let's put these strategies to the test with a few challenges. We'll start simple and then ramp it up.
Here we go, our first challenge. You can see the left side looks a bit more complicated, so let's start there. The whole key here is just to spot something you already know.
Okay, look really closely at that numerator. 1 minus cosine squared of x. That should be setting off alarm bells in your head. It's just a version of our main Pythagorean identity, and we know it equals sine squared of x. So all we have to do is a simple swap.
And once we make that substitution, we've got sine squared divided by sine, which just simplifies down to sine of x. And boom, the left side now matches the right side. Quest complete. First challenge defeated.
Let's level up to challenge number 2. This one looks a little bit trickier, right? We've got 4 totally different trig functions. Now, when you see a mix like this and no obvious identity just pops out at you, that's a massive clue to use our second strategy.
So we're going to break it down. We'll convert tangent to sine over cosine and cotangent to cosine over sine. And suddenly, it just looks like a regular old algebra problem, right? We're just adding 2 fractions. To do that, of course, we need a common denominator.
So we find that common denominator, which is just cosine x times sine x. And then, would you look at that numerator? It's our old friend, sine squared plus cosine squared. And we know that always equals 1. See how one strategy just leads you right into another? It's perfect. And from here, it's a cakewalk. We have 1 over cosine x times sine x. Well, we know 1 over cosine is secant, and 1 over sine is cosecant. And just like that, we've transformed the left side into the right. Challenge 2 complete.
All right, deep breath. This is the final boss. This is the exact problem from the very first slide. It's going to combine all our skills, working one side, combining fractions, spotting identities. But don't let it scare you. We just take it one step at a time.
Okay, first things first, we've got 2 fractions on the left, so we got to add them. The common denominator is just the 2 denominators multiplied together. That leaves us with sine squared of x plus the quantity 1 plus cosine of x squared, all sitting up top in the numerator. Now, we have to tackle that numerator. We've got to expand that squared part, which gives us 1 plus 2 cosine x plus cosine squared x. It looks like a huge mess, I know, but wait, do you see it? We've got a sine squared and a cosine squared in there again. Let's group them together. That sine squared plus cosine squared just becomes a 1. So our whole big messy numerator simplifies down to 1 plus 2 cosine x, which is just 2 plus 2 cosine x. And now we can factor out a 2, leaving us with 2 times the quantity 1 plus cosine x.
And here it is, the magic moment. We have a 1 plus cos of x in the numerator and in the denominator, so they just cancel out. We're left with 2 over sine of x. And since 1 over sine is just cosecant, Our final answer is 2 cosecant of x. We did it. Final boss defeated.
Okay, before we celebrate, we have to talk about a major trap. It's a mistake that is so easy to make, but it's absolutely crucial to avoid if you want to get these right. The single biggest trap is treating this like a normal equation where you can, multiply both sides by something or add something to both sides. You can't do that. You are not solving an equation. You are proving that one side can become the other side. So pick one side and stick with it all the way to the end.
So you might be thinking, okay, why are we putting ourselves through all this? Is it just to pass a test? Absolutely not. This skill has a really powerful and honestly, a very cool real-world use. Literally every time you play a video game or watch a big CGI movie, you are seeing trigonometric identities at work. Animators and programmers use these exact techniques to simplify the super complex formulas that control things like movement and light. A simpler formula means less work for the computer, which means smoother graphics and faster games.
So think about it. We started with what looked like a complete mess of symbols, and we turned it into a simple, proven statement. It really makes you wonder, doesn't it? What other problems that seem impossible in math or really in life are just puzzles waiting for you to find and apply the right strategies?